In this video, we are going to talk about the pressure volume work. Okay, so basically we talked about what is work, what is pressure and volume, and we know that pressure and volumes are state function. However, work is not a state function. Now, how to calculate work use if we are given state functions like pressure and volume? So we are going to understand the the equation that relates work, pressure, and volume. For that, we will consider a gas cylinder, okay, fitted with a frictionless piston. Piston is something that can move up and down in a gas cylinder, and this you have already learned when it comes to working of the internal combustion engine. Okay, so it's a kind of moving piston. It can move up and down in this particular gas chamber. Okay, so you consider a gas cylinder fitted with a frictionless piston, and the pressure of the gas inside this cylinder we represent it as Pg. So it's a constant gas pressure corresponding to the requisite amount of gas present in this cylinder. Now, the variable pressure here is the external pressure, which is the Px. That is the pressure that is coming from the outside. And then the cross-sectional area of the cylinder, and therefore the piston, is simply A, represented by letter A. It's in length square. Unit is length square, whichever, meter square, centimeter square, depending upon the unit that you use. So area of the piston is A. Okay, now suppose your Px, that is your external pressure, is less than Pg. The phenomena that you expect is that this piston is going to move up because pressure X is less than Pg. So obviously, the piston is going to move up. So in other words, here what you can say is that the gas is expanding. Another scenario is if Px is greater than Pg, obviously the piston moves down or the gas is undergoing compression. But for deriving that equation, we will consider this particular situation where Px is less than Pg, and therefore we have the movement of the piston in the upward direction. Okay, suppose during this we consider suppose a point during this upward motion where the displacement that this piston has undergone is a very, very small, that is infinitesimally small distance it has traveled in the upward direction. Okay, and let that be represented by a differential that is dh. Okay, so h. So suppose when there is I told you that during this process the piston is moving in the upward direction, and during this change we consider a very small change. Okay, that small change is represented by dh, the small change in height of the movement of the piston. Let we represent it by a letter dh. Okay, so if this is the displacement that this piston has undergone, we can calculate the work done, because we know that the work done is nothing but force into displacement. So when we are talking about infinitesimal distance the piston has traveled, we will talk in terms of infinitesimal work done. So as I already told you, that work is not is a path function, and therefore we use inexact differential to represent it. So infinitesimally small work that is done is equal to force into displacement. Now, force, let me write it as Fx into the infinitesimal displacement that it has undergone is dh. Now, if you remember the sign convention that I talked about, since this is like, since the piston is moving in upward direction, the work is done by the system. So the gas is doing the work and pushing the piston in the outward direction. So whenever work is done by the system, the sign convention we use for work is negative, and that's why we will place a minus sign outside this expression. Okay, so that is the infinitesimal work done. Let us represent it by an equation 1. Now, let us look into another expression. We know that pressure is nothing but equal to force upon area. Okay, this expression is pretty much known to everyone, that pressure is related to force and area in this particular fashion. Okay, so if you look here, the external pressure here is Px. So we can write pressure as Px, force Fx, okay, that is the force we are talking about, divided by area. Area here is A. Okay, so I can write Px is equal to Fx upon A, or Fx is equal to Px into A. Me write it as expression 2. Now, substituting this value for Fx in equation 1. So that is what I have written. Substituting 2 in 1, what we get, the infinitesimal work done is equal to minus Fx has been substituted with Px and Pa. So minus Pxa, dH is already present there. Okay. Now, A and dH, I have put it in square in the brackets. That is because area into height is nothing but what you call it as volume. Okay, so area into height is nothing but volume. Okay, so therefore this ADH would be representing a small change in the volume that is happening, and that is why we can rewrite this expression as minus Px dV, the small change in the volume. Okay, now this is the differential form of the work done relating to pressure and volume. Now, if we want to know the finite change in the work, we integrate. Okay, so when we integrate the expression, and then suppose we put the initial and final state. Initial state we represent it as I, and the final state represented by F. So I can write over it I and F like written here. And then Px being a pressure term which is not involving any differential. So I can put it outside the integration symbol. So it would be integration dV, which is nothing but V. Okay. So integration dV is nothing but equals to V. Okay. So VIF. So it would be minus Px Vf minus Vi. So Vf minus Vi, that means a finite change in the volume. So this is the expression that relates work with the state functions, pressure and volume. It's a very useful expression which we are going to substitute when we are going to talk about the different laws of the thermodynamics. And here you can see that the sign conventions are pretty well obeyed, because if you talk about the expansion, suppose the volume is expanding from V1 to V2. Okay, volume is expanding from V1 to V2. So that means V2 is a larger value. So V2 minus V1 would be a positive value. So work done in this case would be a negative value. So that means whenever the work is done by the system, the sign convention is negative, so it is obeyed. However, if it is compression, that means work is done on the system, delta V would be negative, so negative and negative will become positive, so the sign convention becomes positive, and therefore the sign convention is perfectly obeyed by this particular expression. Okay, so this is the pressure volume work that we are going to use in the coming expressions that we are going to use for various laws. Thank you. Have a nice day.